Have you ever wondered if we could convert Mars into Earth? A question that seems like it was lifted straight out of a science fiction novel, yet it's a concept that scientists and space enthusiasts around the globe have been mulling over for years. This concept, my dear listeners, is known as terraforming. Terraforming is the process of transforming a hostile environment into one that can support life as we know it. And when we say life as we know it, we're talking about the key factors that make Earth habitable. These include water, oxygen, and an appropriate temperature range. Let's take a moment to consider Mars. This neighboring planet of ours has been the subject of countless explorations and studies, but could it really be a candidate for terraforming? Well, to answer that, we need to look at what Mars currently offers. Despite its barren appearance, Mars does have some promising features. It has polar ice caps made of water and carbon dioxide, just like Earth. The Martian soil contains elements such as nitrogen, which are essential for life, and while Mars is much colder than Earth, with the right adjustments, its temperature could potentially be increased. But it's not just about what Mars has now, it's also about what it could potentially have. Imagine introducing plants to Mars's soil. These plants could produce oxygen, creating a breathable atmosphere, or think about diverting asteroids to collide with Mars, releasing vast amounts of heat and potentially melting its ice caps to produce water. The concept of terraforming Mars is an exciting one, filled with possibilities, but it's also a complex process, requiring vast resources and advanced technology. It's a journey of transforming a desolate red landscape into a vibrant blue world. So, how could we go about turning the red planet into a second home for humanity? Stick around as we delve deeper into this fascinating topic in the next scenes. Imagine a Mars that's not red, but blue and green, teeming with life. What would it take to make that happen? Let's break it down. The terraforming process can be divided into stages, each with its own set of challenges and requirements. Firstly, we need to thicken the Martian atmosphere. Mars currently has an atmosphere just 1% as dense as Earth's, which is insufficient to support life as we know it. To build it up, we would need to release gases trapped in the Martian soil and polar ice caps. This could be achieved through a process called outgassing, using factories to release synthetic greenhouse gases. Now, with a thicker atmosphere in place, we move on to the second stage, warming the planet. Mars is on average about half as warm as Earth. To increase the temperature, we could introduce a variety of methods. One approach might be to erect giant mirrors in space that reflect sunlight onto the Martian surface, thereby heating it up. Another method could involve the use of dark dust spread over the poles to absorb more sunlight, consequently melting the ice caps and releasing stored carbon dioxide, which would further thicken the atmosphere and warm the planet. The third stage would involve the introduction of water. Mars is believed to have vast reserves of water ice, primarily at its poles. By warming the planet, we can melt this ice, creating rivers, lakes, and eventually oceans. Finally, the fourth stage, introducing plant life. With a thicker, warmer atmosphere and bodies of water in place, we could start introducing hardy plants and microorganisms. These life forms would produce oxygen through photosynthesis, gradually converting the Martian atmosphere into one where humans could breathe freely. But this isn't something that can be done overnight or even over a few decades. It's a process that would take centuries. The future of Mars may seem far off, but with scientific advancements and a bit of imagination, it's a future that could be within our grasp. If we were to start the process today, when could we expect to see a green Mars? One of the most intriguing aspects of terraforming Mars is the timeline. How long would it take to transform the barren Martian landscape into a green, Earth-like environment? The answer is, unfortunately, not as straightforward as we might hope. The process could stretch over thousands of years, depending on various factors such as technological advancements, funding, and the human will to persist in this colossal task. The initial phase would involve creating a livable atmosphere. Scientists estimate that with current technology, this could take around 100 years. This process, known as warming the planet, would involve pumping greenhouse gases into the Martian atmosphere to thicken it and increase the planet's temperature. The next step would be to introduce water. Mars does have frozen water at its poles, but for the planet to be truly habitable, we'd need to create oceans, rivers, and lakes. This could be achieved by melting the polar ice caps, a process that could take another 200 years. Once we have a warm planet with plenty of water, the next step would be to introduce life. We would start with simple organisms like algae and bacteria. which would generate oxygen through photosynthesis. This stage could take another few hundred years. Finally, once the atmosphere is oxygen-rich, we could introduce more complex life forms. It would take another few hundred years for the first plants to take root, followed by animals. In essence, we're looking at a timeline of at least 1,000 years before Mars could resemble Earth. The process of terraforming Mars is not a quick fix. It's a long-term project spanning generations. However, it's important to remember that this timeline is based on our current understanding and our current technology. Who knows what breakthroughs the future may hold? While it may seem like a long time, in the grand scheme of things, it's just a blip. A project of this magnitude doesn't come cheap. How much would it cost to terraform Mars? Estimating the cost of terraforming Mars is a gargantuan task. We're talking about a project that's never been attempted before, involving technologies that are still in their infancy. But let's make a rough sketch, shall we? First, we'd need to warm up the Martian atmosphere. A popular suggestion is to manufacture super greenhouse gases, which are thousands of times more effective at trapping heat than carbon dioxide. The cost of producing these gases on a planetary scale? Astronomical. Next, we'd need to thicken the atmosphere. This could involve redirecting asteroids to collide with Mars, effectively bombarding the planet with volatiles like nitrogen and ammonia. Now, the cost of redirecting asteroids is hard to pin down, but considering the expenses of asteroid redirection missions we've already planned, we're looking at figures that easily run into the billions. We'd also need to create a magnetic field to protect the atmosphere and any future inhabitants from solar radiation. This could involve building a massive magnetic shield in space, or somehow reigniting Mars's dormant core. The technology to do this doesn't exist yet, but it's safe to say it would cost a pretty penny. And let's not forget about the infrastructure needed for human habitation. Cities, farms, transportation networks, these would all need to be built from scratch. So, how could we cover these costs? The most likely scenario would involve a combination of public funding, private investment, and perhaps even the sale of Martian real estate. There could also be economic benefits to terraforming Mars. It could stimulate technological advancement, create jobs, and open up new opportunities for scientific research and exploration. It's clear that the costs of terraforming Mars would be astronomical, quite literally. But it's also clear that such a project would be an investment in our future. The price tag is high, but the potential rewards are immense. So, is terraforming Mars a realistic goal for humanity? Let's delve into the current state of space exploration and technology. We've made impressive strides in the last half-century, from the moon landing to the Mars rovers. Our understanding of the cosmos has grown exponentially, yet we still have much to learn. When it comes to Mars, our rovers have given us invaluable insights into the planet's geology and climate. However, the technical challenge of transforming this cold, dry, and radiation-bathed world into a second Earth is immense. It would involve manipulating the Martian environment on a planetary scale, which is far beyond our current technological capability. We'd need to warm the planet, thicken the atmosphere, and generate a stable water cycle, among other things. Each of these steps would require massive amounts of energy, resources, and time. Moreover, there's the question of whether we should even attempt to terraform Mars. There are significant ethical considerations to take into account. For instance, if there is any form of life on Mars, even at a microbial level, terraforming could potentially wipe it out. Is it our right as a species to fundamentally alter another world, potentially at the cost of its native life forms? Then there's the fact that terraforming Mars could divert resources and attention away from pressing issues here on Earth, such as climate change and poverty. Some argue that we should focus on fixing our own planet before trying to create a new one. Terraforming Mars is a concept that fires up the imagination, a grand dream of human ingenuity and ambition, but it's not something we'll see within our lifetimes, or perhaps even within the next few centuries. The costs, both financial and ethical, are enormous, and the technology required is still in the realm of science fiction. It may be a distant dream, but it's a dream that could one day become a reality.